Lesson 404, Tangents and Secants, Part 2. The objectives in this lesson is to develop and use the radius and chord theorem. This theorem says that a radius that is perpendicular to a chord of a circle bisects the chord. You can see that in the picture right here. I've drawn a radius that's perpendicular to a chord. The little red tick marks are telling us that it is congruent segments on either side of the perpendicular lines. The best way to study this lesson is to go right ahead and start working on some examples. Oh, silly me. Didn't get my Mimeo set up. Okay, so let's look at this problem. It says DE is a radius. What is the measure of EC if AC is 2 centimeters? They're showing you that right here. Oh, I guess it'd be helpful if I got my pen going. Let me see. Oh goodness. If it's not one thing, it's another. There we go. They're showing you that right here, that AC is 2 centimeters. The measure of CED is 40 degrees. And the measure of EDC is 50 degrees. And of course we know this right here is 90 degrees because that radius is perpendicular to the chord. And the big thing that, because we don't really know that it's perpendicular, okay, there's nothing in the problem that tells us it's perpendicular, but if you add up 50 plus 40, that equals 90. The triangle sum theorem tells us that all three angles of a triangle add up to 180, so I have to add another 90-degree angle to that to get 180 degrees. So that's how I know that it is perpendicular and that that is a right triangle. Now then, what we learned with the radius chord theorem is that if a radius bisects, if a radius is perpendicular to a chord, then it bisects the chord. So that means EC is congruent to AC. Therefore, EC will also equal 2 centimeters. Okay, here's our next problem. It says BA is a radius. What is the measure of chord BE? Alright, let's look here. BA is a radius. Where's BA? Okay, there it is. Right here. And it's 8 centimeters. What is the measure of chord BE? Okay, if you look right here, you know AD is also going to be, let me write this up here. AD also equals 8 centimeters because it's a radius. And we were told the radius equaled, oops, dotted the wrong thing there, 8 centimeters. Alright, but let's look closer at the picture because I don't think we're going to need that information. It says here that segment BC, let me write that up here. Section BC is 6 centimeters. If you look, this radius AD is perpendicular to the chord, and remember the radius chord theorem says that if your radius is perpendicular to the chord, then your chord segments are going to be congruent because it's going to also be bisecting. So BC is congruent to EC. Write that out there. So that means if BC is 6 centimeters, then EC is also 6 centimeters. So now BC plus EC is going to equal EB or BE, however you want to say it. So you got 6 plus 6 is going to equal 12. So 12 centimeters is the measure of BE. Okay, let's check this one out. It says BA is the radius of circle B. What is the measure of a radius of circle D? Okay, I want you to look closely. Right here is your radius of circle D. Okay, CD is the radius. So, let's look here. We're showing that this is perpendicular. Alright, so we know with the radius chord theorem, let me see, BD is going to equal 12. I'm just breaking down my different information here. And since we know that CF equals 11, okay, and we know that CF is congruent to AC, then we know AC equals 11. So I'm just pulling all our information together. So there we go. We know that BD is 12. So really, what we need to find out is, what does BC equal? Because then we can take BD minus BC will give us CD. And that's what we want to find the answer for, to figure out the radius of circle D. So if we look here, we know we have a right triangle right here. So we can use the Pythagorean theorem to figure out BC. And look how we're going to do this. This is my hypotenuse. AB is my hypotenuse. So I'm going to have AC squared plus BC squared equals BA squared. Okay, so AC is going to be 11. BC I don't know. And BA is 12. So in your calculator, let me get my calculator. Okay, so in the calculator, you're going to type in 12 squared minus 11 squared equals 23, and then you're going to find the square root of 23. Oh my goodness, I did that wrong. Let me do that again. Square root of 23. Let me enter it correctly. There we go, square root 23. And I'm going to get 4.79. We can just round that to 4.8. So let me come back over here, get my pen back, and I can say that, let me do it this way. B squared equals 23. We're going to get the square root of both sides. So BC is going to equal 4.8. Oh, need squiggly lines there, because remember, squiggly lines tell me that it's approximately that much. Let me get, oh goodness, didn't work quite the way I wanted it to. I'm just checking to make sure I answered that question correctly. Okay, so let's go back and finish the problem. I told you that we needed to do this right here. Oh, I hate it when I do that. My arrow wasn't on. Well, I guess it was. Oh, I ended up clearing all my ink. hate it when that happens too. Alright, we figured out with all of the calculations that BC equaled 4.8, or approximately 4.8. And remember, I told you that if we want to find out what the radius of circle D is, which is this CD, we know that BD is 12 because it's the radius. Let me put this up here. Radius of circle B. And if we could find out what BC was, which we did using the Pythagorean theorem, we could just subtract that. We could say BD minus BC is going to give me the length of CD, which is the radius of circle D. Whew, that's a whole lot of letters. So I got 12 minus 4.8 equals CD, and then 12 minus 4.8. I don't do decimals in my head, so let me see what that's going to be. 7.2. And you know, that's still an approximation. So we're going to say that 7.2 centimeters is about the measure of the radius for circle D. Okay, so remember, all you're doing is you're just kind of, you've got a puzzle. Actually, on this one, we were kind of taking it apart and then putting it back together. All right, in this problem, it says BA is the radius. Does the measure of ABC, angle ABC, equal the measure of angle ACB? And explain. Well, let's look here. It says BA is the radius, which is right here. Okay, we also know that AC is the radius, and they have congruent lengths, right? So these guys are congruent. And I'm going to put up here, BA is congruent to AC, and we're going to put both radii of circle A. Now then, because of the radius chord theorem, we also know that this segment right here, let's call this point E. We're going to say that segment BE is congruent to segment C, correct? So we can come down here and we can say BE is congruent to EC because of the radius chord theorem. And then you can look right here, you know, these guys are both right angles, okay? And we can say that these two angles are congruent to each other because of corresponding parts of congruent triangles are congruent. The summary for this lesson: the radius in chord theorem states that a radius that is perpendicular to a chord of a circle bisects the chord. And you can apply the radius in chord theorem to solve measurement problems involving circles. And the perpendicular bisector of a chord passes through the center of a circle. What you should be doing after you watch this video is go through the LMS lesson 404, Tangents to Circles 2, and complete the student guide. Read the lesson in the reference guide and add to your notes if needed. Complete the following problems in the problem set, which is 13 through 21 odd. And if you have any problems with those, please contact me or attend TOGA if you have any questions before you complete the 404 quiz. And then make note of any general questions you may have when you attend CC on Thursday. And then last but not least, Please include your course and section number with all communication to me. That information is found in the upper right hand corner of your geometry LMS. And just to help you out a little bit, your course number is 202B. You really need to tell me you're in 202B, Section 1, Section 2, Section 3, or Section 4. And I tell you what, that information helps me help you so much faster. That's going to be it for the lesson on tangents. Thank you for listening.